Today we'll learn about graphs of functions and transformations. The two transformations that we'll look at in today's video will be vertical shifts and horizontal shifts. We'll look at vertical shifts first. We'll apply vertical shifts to absolute value functions. Absolute value functions are written as f of x is equal to the absolute sign of x. Absolute value functions always have a v-shaped graph, as seen in the figure to the right. When doing vertical shifts, we need to know that the graph of any function, f of x, if g of x is equal to f of x plus k, where k is a constant, the graph of g of x will be the same shape as the graph of f of x, but g will be shifted vertically k units. So if we look at this example where we have f of x is equal to the absolute value of x, and g of x is equal to the absolute value of x plus 2, we'll see that the plus 2 takes place of k, and k is our vertical shift. So a positive 2 would indicate that we would shift our original function 2 units in the upward direction. If 2 was a negative, we would shift our original function 2 units in the downward direction. If we're shifting up in a positive direction, the x values are the same for each function, but the y values for the g of x function will be 2 more than the y values for the f of x function. The graph of g will have the same shape as graph f, but will be shifted 2 units vertically in the upward direction. And the same principle applies to other functions besides absolute functions. If we were to apply our g of x function to our absolute value function in the figure to the right, we would shift each point 2 units in the upward direction. So if we shifted each of these red points 2 units up, we can draw our g of x function. Once we move each point 2 units up, we see that the x coordinate doesn't change, but the y coordinate changes by 2. We can now see what a vertical shift of 2 units would look like if we applied to the f of x function, which equals absolute value of x. We can also do horizontal shifts. We'll look at how horizontal shifts are applied to quadratic functions. We know that we have a quadratic function if the shape of the graph is a parabola. A quadratic function can be written as f of x is equal to ax squared plus bx plus c, or it's commonly written as f of x is equal to a times x minus h squared plus k. If a is positive, the parabola will open upward. If a is negative, the parabola will open downwards. If the value of a is less than 1, then the graph is wider than the graph of y equals x squared. However, if x is larger than a, then the parabola will be narrower than the graph of y equals x squared. The lowest point on a parabola that opens upward, or the highest point when it opens downward, is called the vertex. In the figure to the right, we can see the f of x function when it equals x squared, and we can see the x values and the y values of this parabola when graphed. The horizontal shift can be described as, given the graph of any function f of x, if g of x is equal to f times x minus h, where h is a constant, then the graph of g of x will be the same shape as the graph of f of x, but the graph of g will be shifted horizontally h units. The graph of g and the graph of f will have the same shape, but will be shifted horizontally. The y values of graph g and f will be the same, however the x values will be different. If we look at the example, we have f of x is equal to x squared, and if g of x is equal to x plus 3 squared, we'll see that the x values of graph g will be 3 units less than the x values of graph f. So our graph will shift to the left, and this can be seen in our figure to the right. We can see the original parabola being shifted 3 units to the left when it's x plus 3, and being shifted 3 units to the right when h of x is equal to x minus 3 squared. As with the vertical shift, horizontal shifts work for any function. Now that we know how vertical and horizontal shifts work, Now we can apply them to our two functions that we have below. In our first function, we have f of x is equal to the absolute value of x. And they want us to draw the function of h of x when it's equal to the absolute value of x plus 2 taken to the second power minus 3. So if we look at our h of x function, we have to find what is our horizontal shift and which is our vertical shift. So if we look at plus 2, we see that plus 2 will be our horizontal shift. So first let's apply our horizontal shift. Since it's a plus 2, we're going to shift our original function 2 units to the left. Now we have to see if there's a vertical shift. If we look at 3, we see that negative 3 will be our vertical shift. So that means we will shift 3 units in the downward direction. So if we do so, we will be able to get our final function. Connect our dots and redraw our lines. We'll see that our h of x function is shown below. In our second example, we have a graph of a quadratic function, which gives us an upward opening parabola. If we're given the function of f of x is equal to x squared, and they want us to graph the function of g of x when it's equal to x minus 2 to the second power minus 1. So in this case, our horizontal shift will be negative 2, which will mean we'll shift our parabola 2 units in the right direction. So if we do so, we can draw what our graph would look like when shifted 2 units to the right. Now we'll see if there's a vertical shift in any direction. If we look, we'll see we have negative 1 as our vertical shift. So our vertical shift will be 1 unit in the downward direction. Now we can shift each of our points down 1 unit, and then connect the dots to make the shape of our parabola. And we can see that the final shape of g of x was shifted 2 units to the right and 1 unit downward to give us parabola shape, shown in the graph below.